Pressure and resultant pressure. When a body is immersed in a liquid, it experiences pressure from all directions as shown. Since the horizontal forces acting from one side is cancelled by the opposite forces acting from the opposite side, the resultant horizontal force is zero. We know the pressure in a liquid depends upon its depth from free surface. Since the top and bottom surface of the body are at different depths, the pressure acting on the surface are not equal. Therefore, the vertical forces do not cancel to each other. The difference between these two upward and downward pressure gives the resultant pressure. Students, let ABCD is a rectangular body whose thickness is h. In figure, the pressure of liquid on the surface AD and BC are equal and opposite in direction. So, the resultant pressure is zero. The surface CD is at a greater depth than the surface AB from the surface of liquid. H1 is equal to the depth of surface AB from the surface of liquid. H2 is equal to the depth of surface CD from the surface of liquid. Thus, resultant pressure is equal to the pressure at the surface CD, the pressure at the surface AB. Thus, the liquid pressure at AB, which is denoted by P1, is equal to H1 dg. Also, the liquid pressure at CD, which is denoted by P2, is equal to H2 dg, where g is the acceleration due to gravity, and since we have force is equal to pressure into area, since pressure is equal to force by area, let the body have an area A. Thus, upward force on surface CD is equal to pressure into area. This can be equal to H2 into D into G into A. Similarly, downward force on surface AB is equal to H1 into D into G into A. Therefore, the resultant upward force is equal to H2 into D into G into A minus H1 into D into G into A. Now, let us take D, G and A common from this relation, and we get the resultant upward force as equal to H2 minus H1 into D, G, A, which is equal to H, D, G, A. Since H is equal to H2 minus H1,